Hi, this is Stan Lyle with MasterMath. During the lesson, you're going to come to some You Try It slides where you're asked to do problems that relate to the lesson. Hit your pause button, try the problem, and then hit the forward key to move on to the answer. I hope you have a really good time today.
In this lesson, we're going to learn about some things that you're going to need in order to factor polynomials. And factoring polynomials is real important, and I think it's a lot of fun. So let's get started. You're going to need to understand a few things. And in this lesson, we're going to teach you about the square of a binomial, the product of the sum and difference of binomials, and the zero product property. We'll start with the square of a binomial, and I've drawn a square on the screen here. This is a square where each of the sides is a plus b in length. So, the area of this square would be a plus b times a plus b. That's also a plus b squared, which is the square of a binomial. But we'll leave it a plus b times a plus b. So, if I were to multiply a plus b times a plus b, I'd know the area of this square. But another way I could do that would be to just take the components of the square and sum them. For instance, this component right here is an a by a square, so its area is a squared. And I could put that down there as part of my multiplication, and I'd have a square. Now I can move to another section, this section right here, which is b in height by a in length. So its area is AB. And I could add that to my multiplication down below. This area over here is also AB. So I could add another AB. And our last segment right here is b in height and b in width. So its area is b squared. I'll add that too. So now I've got a plus b times a plus b equals a squared plus ab plus ab plus b squared. I can simplify that to a squared plus 2ab plus b squared. And that's what all square of binomials is going to look like. If I'm multiplying a plus b times a plus b, my results are going to be a squared plus 2ab plus b squared. That's a really helpful bit of information. You try this one. And to make life easy, I've left the pattern down at the bottom of the screen. A plus b times a plus b equals a squared plus 2ab plus b squared. And in our actual example, 2x is my a term, and 6 is my b term. Go ahead and try this. Hit your pause button, try the problem, and then move on to my solution. We'll use the square of the binomials pattern to help us solve this problem. And the pattern says that my first term is going to be a squared, and my a is 2x. So I'll first add a 2x squared. Then I've got plus 2ab. All right, plus 2 times 2x times 6. And lastly, I've got plus b squared. Okay, that would be plus 6 squared. Now I just need to simplify all those terms, and I'll have my answer. 4x squared plus 24x plus 36. Here's another one to try, and it's just like the last one, except that I got a minus sign there. Oh no, what am I going to do? I mean, in my pattern, I've got a plus b times a plus b, and this is a minus b. Oh, what can I do? Well, I'll give you a hint. I could consider minus 6 as plus minus 6. And rewrite this as 2a plus negative 6, that whole expression squared. Okay, hit your pause button, try the problem, and when you get done, hit your forward key to move on to my solution. I hope that hint was helpful. Let's see if it was. Our pattern says that the first term in our answer is the a term squared. 2a is my a term, so I'll put down 2a squared. Next, I got plus 2 times a times b. Well, that would be plus 2 times 2a times minus 6, because my b term is minus 6. And lastly, I got plus b squared, or plus minus 6 squared. When I simplify all those terms, I come up with 4a squared minus 24a plus 36. So, the square of a binomial can be the square of a plus b, or it can be the square of a minus b. And the only difference is that in a minus b, I've got a negative sign between my first and second term in the answer. Here's a second pattern that you need to memorize, and you'll find it really helpful when we get further into factoring. It's the product of the sum and the difference of binomials. If I'm multiplying two binomials that have been summed times the difference between those same two binomials, there's a pattern that gives you an answer real easily. But first, let's solve that with FOIL. FOIL, first plus the outside plus the inside plus the last. So that would give me a squared minus ab plus ab minus b squared. Well, I can see that when I simplify that, my ab's are going to cancel each other out. I got plus ab minus ab. My answer is going to be a squared minus b squared. And that's always going to be your answer when you're multiplying the sum and the difference of binomials. A plus b times a minus b will always equal a squared minus b squared. That property is helpful in mental math as well. Let's say I wanted to multiply 16 times 24. Well, hopefully you can see that 16 is 20 minus 4, and 24 is 20 plus 4. So I could rewrite that as 20 minus 4 times 20 plus 4. And then I could use the product of the sum and differences of binomials to solve that. It would be 20 squared minus 4 squared, or 400 minus 16, or 384.
Now you try this one. Hit the pause button, do the problem, and then hit the forward key to move on to the answer.
Well, my pattern says that my answer is going to be the a term squared minus the b term squared. So, I'm going to have 3x squared minus 4 squared. 3x squared is 9x squared. 4 squared is 16. So my answer is 9x squared minus 16. The zero product property is the last property we're going to work on in this lesson, and it's pretty easy. I mean, you understand that 6 times 0 equals 0. And you probably understand, and it is true, that if my answer in a multiplication problem is 0, then one or both of my factors has to be 0. For instance, if I've got a times b equals 0, I know that either a equals 0 or b equals 0, or both a and b equals 0. Here's an example. Let's say I had x plus 6 times x minus 2 equals 0, and I was asked to solve that for x. I know that x plus 6 equals 0, or x minus 2 equals 0. Now I could solve each of those for x. The first one is x plus 6 equals 0. So I'd subtract 6 from both sides of the equation, and I'd get x equals minus 6. or x minus 2 equals 0. To solve that for x, I add 2 to both sides of the equation, and I get x equals 2. So I would know that my solution to x plus 6 times x minus 2 equals 0 was either x equals minus 6 or x equals 2. Well, that zero product property is going to prove really helpful in the future as we factor more polynomials. And here's an example. Let's say I had 4x squared plus 16x equals 0, and I was asked to solve that for x. Now, that's not a product, that's an addition. But maybe I could factor some stuff out and turn it into a product, turn it into a multiplication property. I could rewrite that as 2 times 2 times x times x. 4x squared is 2 times 2 times x times x. And 16x is 2 times 2 times 2 times 2 times x. And that all equals 0. Well, now what could I factor out? Well, I've got a 2 times 2 times x on both sides of that addition sign. So I could factor out 2 times 2 times x, or 4x. And what I'd have left would be x plus 2 times 2, or x plus 4. I could rewrite that 4x times x plus 4 equals 0. And then I know that either 4x equals 0 or x plus 4 equals 0. If 4x equals 0, I divide both sides of that equation by 4 and I get x equals 0. If x plus 4 equals 0, I can solve for x by subtracting 4 from both sides of the equation, and I'll get x equals minus 4. Try this one. Hit your pause button, do the problem, and then hit your forward key to move on to my solution. Okay, I need to factor 3x squared minus 6x in order to find out if I can solve it using the zero product property. And what can I take out of the 3x squared and the 6x? What do they have in common? Well, I can see a 3x in both sides of that subtraction problem. So I could take out 3x from both sides. And I could rewrite that 3x times x minus 2 equals 0. Then I know that either 3x equals 0 or x minus 2 equals 0. If 3x equals 0, then x equals 0. If x minus 2 equals 0, then x equals 2. Well, that's our lesson on more on polynomials. Get ready to factor. I hope you learned a lot. Now it's time to test your skills. Go to www.mastermath.info and you'll find some worksheets, answer sheets, and quizzes there to make sure you understand this concept completely. Well, have a great time and come back and see us again real soon.